Hi, my name is Kaiter, and this is my Mech 203 final design project. My tricycle has a more toyish yet modern look with accompanying safety features that may be more popular among parents and kid-friendly. The first thing I would like to comment on is the actual wheels of the tricycle. If you can see, it has these thin, large rectangular spokes as opposed to like those thin wire metal spokes. I chose this design over those spokes because this design, oftentimes, kids could get their hands stuck or like their feet stuck in the wheels while it's spinning. I'm talking about other kids here that could injure them, and that's why this design also has this reinforced plastic film, so that the kid actually cannot get any anything stuck inside the wheel. Ultimately, it makes it safer and it gives it a more fun and aesthetic look. For the deck here in the back, we have these ridges that if a user wants to stand on the back here, they would be able to, and these ridges would apply extra traction so that they wouldn't fall off as easily. The overall design of the bike has this low riding design where the seat is oriented closer to the ground. I would say this distance here is about 1 foot, and the handles and wheels are oriented upward and downward respectively towards the seat. This seat is also not a normal triangular seat, but also like an actual chair with like padding and leather, which would make it more comfortable and give back support to the kid while riding. Also to note are the handles. The handles here are downwardly oriented. They go straight down as opposed to horizontally, meaning that when steering it is slightly different, and it's like almost like steering like a rocket ship or like a boat or something, and would give like the user a more like unique feel, even if it's like not as efficient. But kids ride tricycles for fun, not for speed, efficiency, and etc. Over here we have the pedals, which have these holes made inside, so that they're lighter and they provide more traction for the feet, so that kids don't slip. Speaking for the tolerances of the bike, the shafts used for the main body, for the chair, for the front frame, all have basic sizes of 40 millimeters. These connections would use a interference fit of H7P6 according to an ANSI table, but this one here would use a free running fit because it would have to turn. The values for the H7P6 values for the 40 millimeter basic size were 40.042 millimeters and 40.026 millimeters for the shaft for upper and lower tolerances, while for that hole were 40.025 millimeters and 40.00 millimeters for the hole. The axle, on the other hand, has to use for the wheel assemblies. They have these interference fits for the lug wheel and the axle, and for the axle and the pedal and wheel. But for when connected to the actual frame or deck, you would need a free running fit because you would want the axle to rotate. For the interference fits for 20 millimeter basic size, we have 20.048 millimeters for the shaft, and 20.035 millimeters for the lower tolerance of the shaft, and then you would have 20.021 millimeters for the hole, and 20.00 millimeters for the lower tolerance of the hole. For the free running fit, you'd have 20.00 and 19.948 millimeters for the upper and lower tolerances of the shaft, while you have 20.117 millimeters and 20.065 millimeters for the tolerances of the hole. The free running fits would use a D9 H9 values for the ANSI, while the interference fits would use H7P6 values from ANSI. Now let me show you an actual simulation of the bike. Now, as you're about to see, these three wheels move at the same time because the angular velocity set on their servo motors are all around the same. Also, the pedals are given the illusion of not moving relative to the wheel because the angular velocity was also set to the same value, meaning that they wouldn't move. This gives the illusion that the bike is being ridden. And that pretty much concludes our presentation. I chose this color scheme because of personal preferences, and everything is rounded to make the tricycle more kid friendly, and so there's no edges. Thank you for watching my presentation.